All right, I think we're back. So this is part 2. So I'll call it section 3.2 part 1, 3.2 part 2. Is that all right? Okay, everybody with me now? In case anybody's watching this on YouTube, my projector froze and then my whole computer froze and I had to start everything all over again. So this is where we left off. All right. So what is this? This is what? Absolute value, correct? Let me do this first. Okay. So this would be y equals the absolute value of x. Now, I've done this a couple times before. You get the idea. I could take that purple one, that graph, move it up, move it left, move it right, move it down, and that kind of stuff. But this is our parent graph. This is the one that we start with, right? And then you had one. I don't think we've done this one this year, but we definitely did it last year. Do you remember the greatest integer function? Remember that step function? Did we do it this year? Because we did it in my Algebra 2 class. So I can't remember if we did it in here this year. We have done this year? Okay. All right. That's good then. Do you remember this one? Let's change colors. Trying to go different colors every time. That's a little bit different purple. All right, so it goes like this. Everybody watch. So it goes from this integer to the next integer, but then it's open at the next integer, then it pops up to the integer up here. All right, and it goes to the next integer, it's open, pops up to the next one. Right, you remember this, don't you? All right, and then it would go like that. That's open. It would go to here. It would be closed. We'll do one more. All right, and that's your basic greatest integer function. And that would look like this. Do you remember what the, well, I'll just show it to you. Put it in brackets like that. That's the greatest integer function. We're not going to talk too much about it. That's good enough. All right, here's one. I think we may have talked about it last year. I don't know. But we're going to do one more like this. Let's see. I think, are there some more? Yeah. This is the last one, then we'll do an example, okay, with these. This one right here is y equals 1 over x. What do you think that looks like? Let's do the little table. I could just show it to you, but I think it's good to do a little table. So let's go x and y. All right. Could I put a 0 in here?
Yes, you can. No, you can't.
You're not even thinking. You're just talking. All right. Think before you talk. This is right here. This cannot be a 0. Why can that not be a 0? Because you can't divide by 0. So there's no 0 in here. Can it be negative?
Yes.
Yeah, absolutely. It can be negative. So let's put in a. Let's go like -3, and then -2, -1. Again, you can't put a 0. I mean, I could put a 0, but then there's nothing. I'm not even going to put an x. I'll just put a dash, right? There's nothing that can go in there, so you cannot have a 0, 0 in here. So this graph will not cross 0, 0. Can you put a 1? Yeah. Can you put a 2? Can you put a 3? Yes, you can. All right, so let's put some numbers in here. If I put a -3, that's -1/3. This is -1/2. This is -1. Again, you put a 1 in here, it's a 1. Put a 2, it's +1/2, +1/3. So how do we graph that? -3, 1, 2, 3, and then 1, 2. So -3, -1/3. So it's right here. -2 is -1/2. -1 is -1. If I put in, I didn't do this. What if I put in a -1/2? What would this be? Nobody? Are you thinking? Yes, it's a -2. I think you guys are just letting me do all the work and you're not thinking. If I put a -1/2 in here, where would I go? I'd go down here to -2. What if I put a -1/3 in here? Where would I go? Down here to -3. So it's going to look like this. Now that looks like it's going down. It's not supposed to be going down. It's supposed to be going up a little bit. It'll get super close to the x-axis, never touch it. This will get super close to the y-axis, but never touch it. Okay? Everybody see that? Is that the only part of our graph? Now we got to do the positives as well. 1, 2, 3, 1, 2. All right? Again, 0, 0 is not a point. Now we could go 1, 1. That's fine. What if I put a 2 in there? I go to what? 1/2. What if I put a 3 in there? I go to 1/3. What if I put a 1/2 in there? I go to 2. What if I put a 1/3 in there? I go to 3. And it's going to look like this. Okay? All right, so that's what an inverse graph, this is an inverse graph. I should write that down there, inverse. All right, so that's your basic parent function. So when you have to graph something, when it's 1 over something, this is the basic look of it. All right, you could move it to the left, the right, up or down, but that's the basic look of an inverse graph. And the reason we're doing this, so you can just, when you see the equation, you know, you have a basic idea of what it's going to look like. All right, and that's a good starting point. So let's do this. Let's go back to white this time. All right, so here's an actual example from the book. Example 1. And it says graph f of x equal the absolute value of x, and it says graph g of x is equal to negative absolute value of x. Okay? We're just going to sketch it. I'm not going to be super accurate with it, so I'll just use a graph like this. So what they're going to have you do is graph the parent function. This right there, okay, that's your basic parent function. We didn't really do anything to it. It's just y equals the absolute value of x. So what does that look like? Again, we're just going to sketch it. I'm not going to be super accurate. So it's going to be like that and like that. What do you think the negative does to this thing? That's right, because watch. Let's pick the point 1, 1. All right? So what's this going to do? It's going to go 1 what? If I put a 1 in for x, what is this g of x function going to do to it? If I put a 1 in for x, the absolute value of 1 is 1, but then this does what to it? Makes it negative 1. So where's this point going to be? It's going to be 1 what? Negative 1. All right? So it's going to be right here. If I put a 2, I'd go down to negative 2. You see what that negative does for us? What's it doing? It's flipping it, isn't it? What if I put a negative 1 in for x? What's the absolute value of negative 1? Don't worry about him. Just pay attention. It's 1, and then this is negative 1. So if I put in a negative 1, I also go down to negative 1. If I put in a negative 2, I also go down to negative 2. Do you see what it's looking like?
Yes.
It's, whoops. If I can, again, it's not super accurate because I didn't, measure them out or anything like that. But there you go. So what do you think this negative does? The negative outside the function, what does that do to it? It just flips it. That's all it does. Okay? That works for all the other ones too. If you have a negative outside of that function, all that does is just takes your parent function, your original one that you started with, and it just flips it. Make sense? Okay, let's do another one. They call it a reflection about that. We've talked about this before, so I'm just going to go right to the example. So this is example 2. All right, so here's our parent function, y equals square root of x. Do you remember what that looks like? What happens if I add something to it? What does that do to the graph? Okay, it makes it move where? Makes it go up. That's right. When it's outside of that function right here, that plus makes it go up. So what's our original square root of x look like? Kind of looks like that. Would you agree? So what's that plus 2 going to do for us? It's just going to take that thing, and let's say that's 1. It's going to shift it up to here, and it's going to be this exact same shape, except it's just going to shift up 2. What if it said minus 2? Then this would just go what? Down 2, right? 1, 2, and it would just go like that. Does that make sense? So this thing, when you add or subtract on the outside, that translates it, it moves it, it shifts it up or down, okay, depending on the sign. If it's plus, it shifts it up. If it's negative, it shifts it down. Let's do one more. What if I said y equals the square root of x minus 4 right there? So what does this do? Let's watch. Hang on just a second. No, it seems like it would move it to the left. Hey, I said hold on for a second. That means don't stand up. I'm not done. Sit down. This actually, when it's inside of the function itself, this moves it to the right. What if it was plus? It would move it to the left. So this right here would take your original parent function and move it to the right 4 places. And so it would start here, and it would go like that. What if you had both? What if this was square root of x minus 4 plus 2? That means you move it to the right 4 places, and you move it what? Up 2 places, and then it would move like that. All right. There were still a few things we didn't do, but it's really the same thing. We're just doing them with different functions. So I want you to try that homework, whatever it is. There is a part A and part B. Everybody's leaving. Nobody's listening to me. So it's 28. No, let's say it's 20 to 25. Okay, it's numbers 20 to 25. I want you to do those. 20 to 25. And that's section 3 to A. I don't know. You can find 3 too and just look for the problems.